Imagine a star far bigger than our sun, a true giant among the stars, shining with a brilliance that outshines almost everything else in the night sky. For billions of years, this star burns fiercely, fusing hydrogen into helium and creating the elements that make up our universe. But eventually, it runs out of fuel. When that happens, gravity takes over, pulling the star's core inward with unimaginable force, crushing it into a tiny, incredibly dense point. This point, called a singularity, has gravity so intense that not even light can escape its pull. This is what we call a black hole. Contrary to what you might think, a black hole isn't just empty space. It's matter squeezed into an area so small and dense that the laws of physics as we know them begin to break down. To picture this, imagine compressing the entire mass of Earth into a marble. Now, take a star 20 times more massive than our Sun and squeeze it into a space even smaller. The result is a region where gravity is so powerful, it warps the very fabric of space and time, creating a boundary known as the event horizon, beyond which nothing can return. Black holes are invisible to our eyes. They don't emit or reflect any light, making them impossible to see directly, with even the most powerful telescopes. So, if we can't see them, how do we know they're out there? Scientists have developed clever ways to detect their presence. We observe the effects black holes have on their surroundings. Stars orbiting seemingly empty space, or clouds of gas and dust heating up and glowing as they spiral into the darkness. These clues reveal the presence of a cosmic monster lurking in the shadows, hidden but incredibly powerful. Black holes might sound like science fiction, but they are very real. Their existence was first predicted by Albert Einstein's theory of general relativity over a century ago. Einstein's equations showed that massive objects don't just sit in space, they actually bend and curve the fabric of space and time itself. Black holes are the most extreme and dramatic example of this phenomenon, where the warping of space and time reaches its absolute limit. In these regions, gravity is so overwhelming that it dominates all other forces, pulling in anything that comes too close. At the edge of a black hole, the event horizon, our understanding of physics is pushed to its absolute limit, and the rules we know no longer apply. Here, the universe reveals some of its most bizarre and mind-bending secrets, challenging our ideas of space, time, and reality itself. Black holes force scientists to rethink everything we know about the cosmos, and they remain at the cutting edge of astronomical research. They are the ultimate cosmic trap, a one-way journey into the unknown, where anything that crosses the event horizon is lost forever. The existence of black holes proves that the universe is far stranger and more mysterious than we ever imagined, filled with wonders we are only beginning to understand. Black holes are the dark hearts of the cosmos, shaping the evolution of galaxies and influencing the fate of countless stars. And despite all we've learned, they remain one of the greatest and most fascinating mysteries in all of science, inviting us to keep exploring the unknown. Black holes are scattered throughout the universe, but they're not easy to find. The most common are stellar mass black holes, formed from collapsing massive stars. Our Milky Way may have millions of these, wandering like invisible ghosts. We often detect them in binary systems, where their gravity pulls in material from a companion star, creating bright X-ray signals. But there are also supermassive black holes, millions or billions of times the Sun's mass, at the centers of galaxies. Our galaxy's central black hole, Sagittarius A, weighs about 4 million suns. These giants anchor their galaxies, shaping their evolution. How they formed is still a mystery. Did they grow over time, or form huge from the start? Whatever their origin, black holes are the engines at the heart of cosmic cities. Imagine piloting a spaceship through the Milky Way. Suddenly, your instruments detect something strange. The light from distant stars bends and warps. This is gravitational lensing, a sign you're nearing a black hole. The view outside twists and swirls, with stars appearing in odd places. A patch of pure darkness grows, swallowing starlight, the black hole's shadow. Your ship feels a gentle but relentless pull, tugging you off course. You're caught in the black hole's sphere of influence, like a cosmic whirlpool. Communications with Earth become distorted as gravity warps time itself. The closer you get, the stranger reality becomes. You're entering a realm where the rules of physics bend, and everyday experience breaks down. The journey into the abyss has only just begun. You let your ship fall freely toward the black hole, surrendering to the immense pull of gravity. The engines are silent now. There's nothing left to do but drift, as the darkness ahead grows ever larger and more menacing. Time dilation kicks in. Your clock ticks normally, but to distant observers it slows dramatically. Seconds for you stretch into hours, days, or even centuries for those watching from afar. Gravity warps time itself. The stronger the gravity, the slower time flows. Space and time are twisted by the black hole's mass, distorting everything you see and feel. As you fall deeper, minutes for you become years for those far away. The universe outside seems to accelerate, racing forward as you descend. Your ship appears to freeze at the edge, fading and reddening, never quite crossing over. Light from your vessel is stretched to invisibility, a final signal to the outside world. But from your perspective, you keep falling, watching the universe's future unfold and fast forward. Galaxies swirl and evolve in moments. Stars are born and die in the blink of an eye. You're traveling into the future, but it's a one-way trip. There's no escape, no return, only the unknown ahead. The closer you get, the more extreme the time difference becomes. Time outside rushes past, while for you, every moment stretches out, heavy with anticipation. To outsiders, you vanish at the edge. For you, the journey continues. The universe you knew slips away, replaced by a realm where the rules are rewritten. You're about to cross the most famous boundary in physics, the event horizon, where not even light can escape. Beyond this point, all bets are off. The black hole's edge is near, and the laws of reality are about to change forever. There's no turning back. The ultimate frontier awaits, and your journey into the unknown is just beginning. You approach the event horizon, the point of no return. This is the boundary that separates the known universe from the unknowable depths of a black hole, a place where the rules of physics as we understand them begin to break down. It's not a wall, but an invisible boundary in space. There are no signs, no glowing markers, just the silent, unseen edge where escape becomes impossible. Once crossed, escape is impossible. Gravity's pull exceeds even the speed of light. Not even the fastest thing in the universe can break free from its grasp. Imagine a river's current growing so strong you can't swim back. This is the event horizon. No matter how hard you try, the flow drags you forward, deeper into the unknown. Inside, space-time itself falls inward faster than light. Everything, even light itself, is swept along by the unstoppable pull. Crossing it feels uneventful, especially in a supermassive black hole. No alarms, no sudden change. You might not even notice the moment you pass the threshold, but the outside universe vanishes. All paths now lead inward. The familiar stars and galaxies fade away, replaced by an all-consuming darkness. Your future is sealed. You can only move toward the center. Every direction, every possible path, now points to the singularity at the heart of the black hole. Time and space swap roles. Forward in space means inward, with no way out. The very fabric of reality twists, and your sense of direction becomes meaningless. The fabric of space-time pulls you relentlessly toward the singularity. Every second, you are drawn closer, unable to resist the immense gravity. There's no standing still, no escape. The journey is inevitable, and the laws of nature offer no mercy. The journey inside a black hole is a one-way trip. Once begun, it cannot be reversed or undone. The universe outside is lost to you forever. All that remains is the endless descent, and the memory of the cosmos you left behind. You are now part of the black hole's story. Your matter, your energy, your very existence, becomes woven into its mysterious depths. The most extreme laws of physics now rule your fate. Your destiny is set, governed by forces beyond imagination, in a realm where time and space themselves are forever changed. Inside the black hole, tidal forces become deadly. Gravity pulls harder on your feet than your head, stretching you out. This process, spaghettification, turns you into a long, thin strand of atoms. For small black holes, you'd be torn apart before even reaching the event horizon. In a supermassive black hole, you might cross the horizon intact, but soon the stretching force becomes irresistible. Your body is pulled apart, atom by atom, into a stream of particles. This is the ultimate deconstruction, matter reduced to its most basic form. The journey is brief and brutal. No human could survive it. You become part of the black hole, your atoms lost to the darkness. The final destination is near. If you could survive, you'd approach the singularity, the black hole's center. Here, physics breaks down. Matter is crushed to infinite density, space and time lose meaning. The singularity isn't a place in space, but an endpoint in time. It's where the known laws of nature collapse. Quantum mechanics and general relativity must unite here, but we don't yet know how. Your particles merge with the singularity, adding to the black hole's mass. This is the end of your journey, and the end of space-time itself. The singularity remains the greatest mystery in physics. Some physicists wonder if the singularity is truly a point of infinite density. Quantum effects might prevent total collapse, creating a dense but finite core. Others speculate black holes could be gateways, linked to white holes or even other universes. The idea of wormholes or Einstein-Rosen bridges is mathematically possible, but likely unstable and fatal to travelers. No evidence supports these ideas, but they push the boundaries of imagination. Could black holes birth new universes? It's a tantalizing thought. The truth is hidden inside, beyond our reach. Black holes remain the ultimate locked room of the cosmos. We can only guess what happens within, piecing together clues from the outside. The mystery endures, fueling our curiosity. Why study black holes? Because they are the universe's ultimate frontier. They test the limits of gravity, space, and time. By observing them, we probe the deepest laws of reality. Black holes challenge our understanding and inspire new questions. They drive technological innovation, X-ray telescopes, gravitational wave detectors, and more. The quest to understand them is part of humanity's drive to explore. Black holes remind us how much we have yet to learn. They are cosmic teachers, showing us the universe's strangest secrets. As long as mysteries remain, we'll keep searching for answers. The adventure continues, and the cosmos still has secrets to reveal.